All right, so we have already got our tab labeled with page 79. The title is 13.3, Solving Absolute Value Equations. We're going to finish solving absolute value equations today. So we're going to go ahead and label page 79 the same thing, 13.3, Solving Absolute Value Equations. We will finish that in this video. Make sure you label your page. This is where we're going to come back and glue that in just a second. So you have a foldable bottom of this video. It might have been in the first video and not in this video, but it's the second set there. So let's go ahead and get started on that foldable. Alright. The second day of these. We're still doing the same thing. It's still the same process. They're just going to be a little bit different. So number 6, we have absolute value bars. We've got 2a plus 5 inside of those. And we have this negative 2 on the outside. That is what we have to get rid of. In order to get rid of it, we are going to have to do the opposite. You need to remember that when there's a number right next to something, there's a multiplication symbol that's not visible, but it does exist. So we are actually doing the opposite of multiplication, which is dividing by negative 2. So 2a plus 5 is equal to 11. Again, like yesterday, we have to create two cases because we now have our absolute value by itself. So a negative 11 and a positive 11. Subtract 5. 2a equals negative 16. A equals negative 8 is one of our answers. Subtract 5. 2a equals 6. Divided by 2. A equals 3. Here are my two solutions. Go ahead and start number 7. Pause the video if you need to. All over again, I got to get the absolute value by themselves. So I'm going to subtract 2 as that's the opposite. Absolute value of negative 6 minus 2n equals negative 18. And I have a problem. Here's my problem. It is not possible for an absolute value to equal a negative number. There's no number that the absolute value of is negative. We did have a negative here, but when we got to the absolute value by itself, we had a positive. So this one was fine. This one is not, because when I have the absolute value by itself, it equals negative, which is not possible. Since it is not possible, my answer is no solution. I know it is a no solution because an absolute value by itself cannot equal a negative number. So if you see that, after you get the absolute value by itself, you cannot continue. You need to write no solution. So it's possible to have two solutions. It's possible to have no solutions. Let's see what else may or may not be possible. If you remember relating this back to systems of equations, we could have 2, we could have 1, we could have no. There might be a chance that we have 1. We'll have to see if we work through this. So opening this up to number 8. This one's a little bit more going on. I've got a negative 6 minus 9. The biggest mistake that students make, and you may or may not make this, is doing negative 6 minus 9 and writing down negative 15. This is not negative 15 because you have negative 9 times this absolute value. You cannot add these together or combine them, so do not combine them. We are going to deal with this negative 6 first by adding it to the other side. We're going to bring down the negative 9 and the absolute value bars. It's a good idea to make them longer because you don't want to mistake them for 1s. And that equals 0. I still have something with the absolute value bars. Remember I said this is multiplication, so I'm going to undo this by dividing. The absolute value of p minus 8 equals 0. We have finished step 1. We are ready for step 2, which is to create two cases, a positive and a negative. Well, I have a 0. Negative 0 is not a thing. 0 is a neutral number, which means it is neither positive or negative. So I can't create two cases if I have a 0 here. I have to create one case and solve this equation, which means there is only one possible answer for this question. So we could have two answers, we could have no answers, or we could have one answer. Two solutions, one solution, no solutions. Let's work with number 9. Number 9, I have to get the absolute value by itself. I'm going to move over the minus 4. I know that's the one I want to move over because I always need to move anything that is added or subtracted before I move division or multiplication. All right, I'm now going to divide by 9. So the absolute value of v plus 10 equals 2. Okay. And I've got two cases. So this one came out like the other ones we have seen. Nothing special about this one. And I'm going to subtract 10 to finish solving these. Now, don't get freaked out because you get negatives. Remember, that's okay because when I plug it back in, the absolute values can change it so that it's not a negative at the end answer. So make sure it's all right to have a negative as the answer, just not when the absolute value bar is by itself. So I do have two. They are both negative in this situation. Just so you know, remember you can always go and plug these back in to make sure they work. So negative 12 plus 10 is negative 2. The absolute value of negative 2 is 2. 9 times 2 is 18. Minus 4 is 14. So it's a good idea to be able to plug these back in and make sure they work. Last problem that we're going to do for these is number 10. Number 10, again, I've got that situation where I told you this does not mean I have negative 3 plus 10. This 10 is multiplied, so I cannot add those two together. So I'm going to move this 3 first by adding it. I'm adding it because it has a negative, not because this is positive or anything like that. We're not looking at that symbol. So 10, absolute value of 6 minus 2x equals 60. And we're going to divide by 10 to get the absolute value by itself. So the absolute value of 6 minus 2x equals 6. Ready for the two cases. 6 minus 2x equals negative 6. And 6 minus 2x equals positive 6. I will then solve each. I'm subtracting 6, not adding it. I don't look at this symbol. I'm looking at the symbol in front of the 6. That's a common mistake, is to use this symbol when I need the one in front of the 6. So negative 2x equals negative 12, so divide by negative 2. X equals positive 6. Again, to check, you can go plug it back in for x, see if it works out. Alright, again, subtract 6. Remember, these are actually the same process. I just will get a different solution because this is a positive instead of a negative. So negative 2x equals 0. And then x equals 0. So here are my two solutions. Just a recap of some key points you should know from absolute value equations. How many solutions does an absolute value equation have? It can have no solution. It can have one solution. And more than likely, as we have seen a lot, it can have two solutions. how do you know how many the equation is going to have? When the absolute value is by itself, we know there is no solution if there is a negative number. To make sure you can see that, you cannot. Zoom out just a little bit. We know it is one solution if the number is 0. And we know there are two solutions if there is a positive number. This is a good reminder so that you do not do extra work and solve for something that is not possible.
Alright, now that we've finished those notes, we're going to glue those in on page 79. So go ahead and grab your foldable, your glue stick. I'm going to glue this in right here on 79. We are finished with absolute value equations, so you should be able to finish the 13.3 homework, whatever that is. Make sure you turn that in. And we will start absolute value inequalities in the next video. See you then.